Welcome back. What's up, everyone? So today we're gonna talk about something that is equivalent to pre-calculus level questions, which are solving inequalities of polynomials. So this video is going to be long, so I decided to break it into two parts. So first, we're going to look at two examples and see how we can solve those inequalities of polynomials. Then for the next video, which is a video for tomorrow, we're going to look at some general cases. Okay, so first, let's figure out how to solve the inequalities up here. And then, yeah, for the detail part, we'll leave it for tomorrow. All right, here we go. First, we have the inequality 3x squared minus 8x plus 4 is greater than 0. I guess most of you, when you learn it in math class, the teachers will always tell you to first set it equal to 0 and then try to solve for the x's, meaning that we're technically assuming that it is equality, and then solve for such polynomial expression to find out the solutions of x. And in fact, this is actually the best way to do it, but do we really have to set it equal to 0? Not necessary. Okay, setting it equal to 0 is just helping us try to factorize it. But no matter what, we still need to factorize it so that it will be easier for us to do the following steps later on. So here we go. If we look at the right hand side, we already have 0. So all we need to do is now try to factor out the left hand side, which again, we can just use the cross to help us. So we would, here the leading coefficient is 3, meaning that we only have one option, 1 times 3. If we ignore the negative sign, because we can of course adjust it with the constant term. Now on the right hand side, well, I shouldn't say right. For the constant term, we have positive 4 here. So we now end up with a couple options. Suppose that is factorable. We have either 1 times 4 or 2 times 2, or we can have negative 1 times negative 4 or negative 2 times negative 2. But here is a hint in the middle. For the x term, we see the sign is negative, so we might as well just put negative for both terms, so that after we cross multiply, we have negative plus negative, so that we can get negative back. If we leave it as positive, we will have positive value plus another positive value, which of course will give us a positive value. That is not what we're expecting to. So now we need to figure out whether we put 1 here, 4 here, or 2 here, 2 here, or 4 here, 1 here. But again, after we check all the cases, the only possible case is putting negative 2 and negative 2. So we can verify quickly. We have 1 times negative 2, which gives us negative 2. And then here we have 3 times negative 2, which is negative 6. So we have negative 2 plus negative 6, giving us negative 8, which is the coefficients that we're looking for. Great. So we now can factor it into 3x minus 2 times x minus 2, which is the left hand side, and then we want to keep everything else the same, greater than 0. Now, perhaps you might ask, does it really matter whether we put x minus 2 first or 3x minus 2 first? Not really, because again, we call that commutative, meaning that we can put either one first and then the other one the second, and then the products will still end up with the same result. But now, most of the time, the teacher will just tell us to set equal to 0, and then we're trying to look at the graph, right? Here, we don't have to do it that way. In fact, there is a reason why I will rewrite into this order, 3x minus 2 and x minus 2. Okay, so again, if we assume that these two are solutions Then we have x equals 2/3 for the first term. And then we have x equals 2 for the second term. Why do these two matter? Because what we're going to do the following is we're going to make a table, and then for first row we call it x, which will be the x values up here, and then for the second row we can call it y, or some people will just call it f of x if you want to set it as a function, doesn't matter. But after that, for the table that we have, we're going to do the following. Since we technically got solutions 2/3 and +2, we're going to make a table and then write down the two solutions. And also for everything else, we'll just put it as dots. So what does that mean? It means that now we consider all possible x values, meaning that the whole real line, and we're going to use these two solutions as our cutoff points, meaning that we're going to think it into three parts. The solutions will give us, of course, 0. And then for everything before the solution and everything after the solution, we will treat those values as the same group. Okay? Well, when I say group, I don't really mean the group in abstract algebra, but yeah, bear with me. Here, we're just thinking it as like including everything after. For example, here, the 3 dots after 2 means that we could think of any value that's greater than 2, such as 3, 5, 10, 100, 3,000, anything you could think of, even pi, okay? Now, why do I want to put those together? Because the following does not depend on the actual value of y anymore. All I care is whether I'll get a positive result or negative result after I substitute in. What do I mean? For example, let's say if I'm going to pick some value in the far right part, let's say 10, okay? Then I'm going to substitute the 10 into our expression up here, or you can put it in here, so that we see that we have 3 times 10, which is 30, minus 2, giving us 28, times the second factor, which is 10 minus 2, that is equal to 8. So we have 28 times 8. What is that? Doesn't matter. All I care is whether it is positive or negative. But clearly it's a positive because we have a positive times another positive. So is it always true? Well, we can think it this way. Pick any number here. We see that this number is bigger than 2. Therefore, that number minus 2 is still always positive. Okay? So, similarly, we can argue that if we pick any number that's bigger than 2 here, well, we're going to first multiply by 3. So that's 3x is always greater than 6. Then, if we subtract it by 2, we still have it greater than 4, which is always positive as well. So we can guarantee that no matter what number we choose here, the first factor is always turning into a positive value. And then the second factor is also going to be positive, so that we have positive times positive, giving us positive here. Good. So we can use a similar argument to check that for here, the far left part, the first term is always negative, and then the second term is also negative, no matter what value we choose, ending up with negative times negative, which is positive overall. And in the middle, we see that we get positive from the first factor. However, we'll always get a negative value from the second factor, meaning that we always get positive times negative. So we end up with negative. So with the charts here, we now can conclude that the solution sets that we want for the expression or the inequality above is everything that is strictly less than 2/3 or everything that is strictly greater than 2. And again, why is that the case? Because we want the expression on the left, which is equal to the y value that we just set up, to be always greater than 0. In other words, we want it to be always positive. Since from this chart, we see that no matter what value we choose that is less than 2/3, we always end up with a positive value. It means that all the numbers that are strictly less than 2/3 will be the part of the solution. And with the similar argument, we can just claim that all the values strictly greater than 2 will always end up with positive, which means x is greater than 2 is another part of the solution for this inequality. Excellent. So let's move on to the second one. So for the second one, we are going to do the same thing. Again, we don't have to set it equal to 0, but technically we still want to find out the solutions like what we do. So to do that, of course, we would like to move all the terms from the right hand side to the left hand side, which gives us this: x to the 4th power minus 7x cubed plus 17x squared minus 17x plus 6 is less than or equal to 0. So how do we factor this out? Well, we can use some of the theorems, but here is what we're going to do. It's called the remainder theorem, but anyway, I'll just skip the theorem itself and just jump to the conclusion. We will be able to get x minus 1 squared times x minus 2 times x minus 3 for the left hand side, which is less than or equal to 0. Good. And again, how do we get these values? We can use the remainder theorem by substituting these values and check whether we'll get 0 or not. And after that, we'll just factor out the polynomial. Good. So now we have the factored form of the polynomial. We see that we have 3 solutions. Well, in fact, we have 4, but there's a repeated solution. So we're going to do the same thing again. Make a table and then divide it up into a couple parts. So we need 1 here, 2 here, and 3 here. And then we also have other regions. Good. So we of course get 0 here, 0 here, 0 here. We can quickly check that by substituting 1 here. This gives us 0, so we have 0 times anything, so ending up with 0. Similarly, if we substitute 2, the middle term turns into 0, giving us the whole y value is equal to 0. And if we substitute 3, we get the last term being 0, so y is turning into 0 as well. Good. So next, what should we do? Well, again, we can just use the same argument. Let's say if we're going to pick some value here, here, and here, respectively, and then we'll be able to check it. So let's see, if we pick something that's less than 1, of course, this x minus 1 is going to be less than 0 then. In other words, it will turn into negative. But then this argument will be true for x minus 2 and x minus 3. So we have negative, squared, so we have 2 negatives here, 3, third copy, fourth copy. So we end up with negative squared times negative, giving us 1, 2, 3, 4. We have 4 negatives, which is positive. Good. Next, let's say if we're going to pick some value between 1 and 2. Well, we see that if we choose a value that's between 1 and 2, x minus 1 is turning into positive because that value is bigger than 1. So this provides us a positive, square root is also positive. Now, if we choose the value that's between 1 and 2, that value is less than 2, of course, so x minus 2 is negative. But that's also true for x minus 3, because if it's less than 2, it must be less than 3. So we end up with positive squared times a negative times another negative. So we have double negative. We end up with positive. Now, if we choose a number that's between 2 and 3, we see that this is positive, but this is still negative because it is still less than 3. So we have one negative here, we end up with a negative sign. Last but not least, we need to check numbers that are greater than 3. So again, we see that if it's greater than 3, x minus 1 is positive, x minus 2 is also positive, x minus 3 is positive as well, meaning that they're all positive. So the product is also positive. Good. So now, what do we want? We want the results of y as being 0 or negative. So which parts satisfy? Well, since we want to get 0 as well, don't forget we have this part here. We need this part, and we want it to be negative, and we also need to include the 0 here. But then we don't want any positive parts. So let's see what are corresponding to these results. We have 1 here, 2 here, everything between 2 and 3, and 3 as well. So now we can give our conclusion. We can conclude that x is either equal to 1, or x is between 2 and 3, and this time we would like to include both endpoints because those are also part of the solutions. So we end up with x is equal to 1, or 2 is less than or equal to x, which is less than or equal to 3. That's it. So this is how we can actually solve the inequalities of polynomials without actually setting it into 0. And this is probably something that some teachers might actually not teach you in class. That is actually more straightforward than graphing the actual function before and look at the function to tell which parts of the regions we want to take as our solutions answer. Good. So this is not the end of this idea. For tomorrow's video, again, we're going to look at a more general case, and we're going to talk about what are some shortcuts to actually solve the inequalities of polynomials without actually doing the stuff that how usually textbook teach us, and probably something we're probably gonna go over some shortcuts that probably you have never learned in class either. That's it. So if you enjoyed this video, don't forget to like, and then again subscribe my channel so that you can check out my other videos. Also turn on the notification so that you won't miss any of my new videos either. And if you have any thoughts or some ideas or questions, you can also leave your comments below, and I'll try to answer all the comments as soon as possible. Thank you very much. I'll see you guys in the next video.